Hi, my name is Madison Shelley, and I will show how to look at a molecular formula and spectrums and come up with a proposed structure. First, we can see that the molecular formula is C10H12O. Next, we wanted to look at the degree of unsaturation. The degree of unsaturation is, for this, because we only have C's, H's, and O's, it's going to be 2 times our C, which is 10, plus 2 minus our H's, which is 12, all divided by 2, which equals 10 over 2, which equals 5. This shows us that we are most likely going to have an aromatic ring and an additional double bond. The first graph that we can look at is here. It's called an IR graph. This is going to tell us the functional groups that we have. So we'll go through the values to determine the functional group. This group over here by 3000 shows a likely sp3ch group. This spike over here at about 1700 shows a C to a double O group. When we have a C to the double O and there's only one oxygen present in the formula, we are often thinking of aldehydes and ketones. To distinguish between aldehydes and ketones, aldehyde would have a spike here around 2800, and this graph does not have that. So we can assume from this information here that we're going to have a ketone. The next value that we can look at are the spikes here between 16 and 1400. And this tells us about C to C, which is common for aromatic rings. And then we have one more group to look at here between 1400 and 1200, and this gives sp3c bonds. All of this is not important to look at as it's just fingerprints. So what we know from this information is that we have a ketone and an aromatic ring. The next chart that we will look at will tell us about the specific carbons on the groups. First, from 200 to 100 tells us that we have sp2 bonds. And then from 0 to 100, we have sp3 bonds. This group, this spike right at 210, tells us that one of the unique carbon groups is a C to a double O. This group right here between 220 and 240 is common for our aromatic ring, which is 6 of the carbons. And then these two spikes right here tell us that there's 2 other carbon groups that are just sp3 bonds. So to summarize this information, we have 10 carbons total One of them will be double bonded to an O. 6 of them will be in our ring. And then we have 3 left over that will be sp3 bonds. 2 of them will be identical, and 1 will be on its own. To see how these carbons fit in together, we then look at the hydrogens connected to the carbons. So we see that we have 4 different hydrogen groups. We can first look at this one. There will be 2 hydrogens. And to look at these 2 hydrogen groups, we can see that there are 2 spikes, which means it's a double, which means the neighboring carbons to the hydrogens will have 1 hydrogen. When we look at this spike, we know that there will be 3 hydrogens that are identical. And we can see that there are 3 spikes in here, so it is a triple. Which means there will be 2 hydrogens on the neighboring carbons. This value right here is typical for our ring that we have. Because we know 1 will have to have some other group on it, we will have 5 hydrogens here. These 2 hydrogen are identical because the neighboring carbons only have 1 hydrogen. So that is reflected in the same color highlight. And then we know that these 3 are reflected in the same other. There's 3 of those, and they have 2 neighboring hydrogens. So that gives us our 1 ring. We then know we only have 2 other unique hydrogens. And we know that we have the ketone. So our double bonded C is going to be connected to, we don't know which carbons, but they will be carbons, so there will be no hydrogen group on that. And then we have our 3 other C's. 2 of them will be identical. And from this information up here, we have 1 H. We obviously cannot have 1 H and make things identical, so the H will have to be on this C. And then this C will have to be bonded to 3 other things that we do not know what yet. This 1H also tells us that it has 7 spikes. So there will be 6 hydrogens on the neighboring carbons. Now we have our 6 hydrogens that are left over here. And we can see that there are 2 spikes. So the neighboring will have 1, the neighboring carbon will have 1 hydrogen. So when looking where we can place our last 6 hydrogen, we know that we can place them on our identical C's. And we know that this has a bond open, this has a bond open, this has 2 bonds, this has 2 bonds. So now we can link everything together. So let me do this a little easier. These are going to go to the C because they're going to be identical. This can bond to the ketone, and the ketone can also bond to here. So then we have our final product. that looks like that. And you can see it all summarized in this table here. First, we learned about what functional groups we had. Then we learned about where our C's will be placed and where the H's will be placed in order to put all of the C's together and get our final proposed structure.